So on Canvas, you've got access to this Brain Fuse online tutoring that you can do. You click on that, it'll take you. I don't think it'll work with me, but uh, yeah. Let me leave student view and click it. You can go here, click that, and it'll come up and it'll have this launch Brain Fuse button. Click that. And this is all free and part of your UTM tuition. You pay for this whether you use it or not. Okay. So it would take you to a page here, and you pick out what course you're in, and then it'll ask you what class is it, and then it will connect you with a actual person. It'll be like text message style, but they will also have like a whiteboard that they can write things on, and y'all can communicate back and forth getting help. Okay, so it's like an online tutor. It's an actual person that's vetted and qualified to help with math. Okay, so this is still out there for you. I don't want you to feel like you're all alone. You can always email me if you've got questions. I will gladly, if we need to Zoom so I can explain something to you, we can. Or if I need to just make you a video and send it to you, I can do that too. So don't feel like you can't email me. I want you to. Okay. But this is just another thing that's free and part of your UTM money that you're giving them is this Brain Fuse online tutoring. It's free. It's not somebody probably here in West Tennessee. I don't know where they're at, but they're people that can do math and they can help you if you're struggling. If you're struggling with conceptual idea, you can tell them what you're struggling with or what you're studying, and we're solving equations, and I'm having a problem. I don't seem to ever be able to get the answer right, and they'll say, "Can you give me?" They'll ask you for an example, and you can either take a screenshot of the problem you're working, or you can write in the problem that you're working. You'll get the whiteboard too, and you could write in with your mouse or if you've got a tablet, you can do it with that, or on your phone, that sort of stuff. So it works through the Canvas app as well. So it is free for you to use and available for you. So I want to just reiterate, it's out there. So you can get help even if you don't have somebody that you can call. Okay. But you can always email me and get help from that. But you got this out there too. So when you're sitting there frustrated, think, hey, I want to take a break for a second. I'm going to let this person kind of try to explain it to me. Maybe they explain it in a different way that clicks with you. Because once it clicks, you're going to be fine. But maybe you just need somebody else to explain it in a different way, or they worded a different, just one or two words different can make all the difference as far as you understanding that. So I just wanted to refresh you on the fact that exists and that's out there, and you can use that to help you get better at this stuff and understand what's going on. Okay. All right. So let's jump into tonight's stuff. So the first lesson that we're going to do tonight is 1.1, chapter 1, lesson 1, linear equations. So we're going to be solving linear equations. So solve for the given variable. So all we're doing is good old solving equations. We'll start with an easy one. X plus 7 is equal to negative 3. So a nice, easy equation. So the idea here is that we're solving for x. Get x by itself. So you want to isolate the variable. You're going to use inverse operations to do that. So in this problem, over there with the x, you got an x plus 7. So to get rid of that 7, we're going to use the inverse operation of that plus 7. The inverse of addition is subtraction. So I'm going to minus 7, and I'm going to do it to both sides. And then on the left-hand side, positive 7 minus 7, that cancels each other out. All that's left over there is x. And on the right-hand side, we just have this problem, negative 3 minus 7. So two negatives make more negative. So that's going to be negative 10. Once you get x by itself, you're done. The great thing about solving equations and getting answers is you can plug them back in to see if they're right. If I plug that back into the problem, is negative 10 plus 7 -3. Yes, that checks. That's correct. Okay, so that's the nice thing about solving equations is you're going to be able to check your answers. Go right there beside it and do a little short one here. 2x is equal to +18. So when they mash them together like that, 2 and x are doing what? They're multiplying. So 2 times x, the inverse operation of multiplication is division. So we're going to divide by that 2. On the left-hand side, 2 divided by 2 cancels out. That leaves us an x. And on the other side, we're going to work that out. If it goes into it evenly, great. If it doesn't, reduce the fraction. 18 is divisible by 2 how many times? 9 times. And you're done. We can check that. 2 times 9 is definitely 18, so that's the right answer. So you can always check your answers with the equations. It's nice. That's what makes it wonderful. Let's go to something that's a little bit more than one step. Let's say 2x plus 7. So kind of combining the two problems above. And then I'm going to set it equal to -5. So in this one, you've got some extra stuff with the x. You got 2 times x and then the plus 7. So isolating the x takes a little bit more work, but you want to move the things that don't have the variable first. So I'm going to move that 7. How do I move it? Subtract it. So to cancel it out, I'm getting rid of it. I'm going to subtract it because they added it, the inverse operation there. That's going to leave me 2x is equal to -12. And then to get rid of that 2 or to cancel it out, I'm going to divide by this 2 on both sides. And that's canceling out there, and x is equal to, that goes evenly to be -6. The nice thing is I can check that in the problem to make sure it's right. 2 times -6 is -12 plus 7 is -5. So that checks in the original problem. So it worked. Let's get one that's a little bit more difficult. Let's put 3x minus 7 equals 10x plus 14. So this one has plain numbers and x's on both sides. So we've got to make a decision about which way we like to go. So we want plain numbers on one side, letters on the other. It does not matter which way you decide to move things. Most of us, over the course of our mathematical lives, had rather have the x on the left-hand side. We'd rather have it over here and then the number on the right side. That's absolutely fine, and it works. So that tends to be how I do things, but it doesn't matter. If you would rather move it over to the other side just because it's easier, that's fine. But I'm going to move the stuff that doesn't have x's first. I'm going to move this 7 by addition because they were subtracting it. The opposite of subtraction is addition. So that's going to cancel it out, and that's going to leave me 3x equals 10x plus 21. Now I can see that the right-hand side is overloaded. It's got too much stuff on it. So I need to move that 10x back to the other side with the 3x because they're like terms. They have the same x on them. So that's a positive 10x. How do I get it? How can I move it over to the other side? Yeah, I'm going to subtract 10x. And that's going to cancel it out on the right-hand side, which is what I wanted to happen. And that's going to give me 21 on the right-hand side. On the left-hand side, what is 3x minus 10x? -7x. And we're one step away from solving that. Yeah. Divide by the -7. X is -3. Now, I'm doing this one step at a time. Some of you may be more comfortable with this and may be okay to do more than one step at a time, and I'm good with that. But I'm just when I'm doing the notes, I'm gonna do it one step at a time so that I don't lose anybody. Because some of us, it's been a minute since we've done this. Some of us, we did it, and it ain't been a minute, but we weren't very good at it when we did it the first time. So maybe this helps us get better at it because this is going to be essential in solving problems the rest of the semester and all the next semester. So let's get good at it now. All right. Jones, go ahead.
Sorry.
Where at?
Why did we, so we had negative 7x equals 21.
Mm-hmm.
We didn't subtract the 7?
Right, because what's going on between the 7 and the x is they're multiplying. The inverse operation of multiplication would be that division. That's the reason we didn't do that. Yeah, that's good. That's good. That as long as we clear it up, we're good. Anybody else? All right, let's go to another one. It's very similar problem. Let's do, what letter are we on? E. Let's say we had 5x minus 8 equals negative 2x plus 7. Okay. We're making up a new one, kind of same idea, but just changing up some signs and stuff on us. So again, we want to get the plain numbers together and then the x's together. I usually move the plain numbers first. That's just how I've always done it since I was in Algebra 1, okay? So that's, or pre-algebra, wherever I learned that. So the first thing I'm going to do, I like to move my x's to the left. So I'm going to move that 8 over to the right just because that's how I like to have it. I like having x on the left. Not that it matters. So I'm going to move that 8. How do I move that 8? Plus 8. So that's the inverse of subtracting 8 is adding 8. So that's canceling that out. So I got 5x, and then I got negative 2x plus 15. Now, I got it heavy over here on the right hand side. I need to get the x's together. So how do I move that negative 2x? I'm going to add it. So that's going to be 7x equals 15. Now on this one, what's going on between the 7 and the x? They're multiplying. The opposite of that would be division. So when I divide that, does 15 divided by 7, does it go evenly? No, it doesn't go evenly. So I'm going to try to reduce that fraction if it will. If it won't reduce, which this one doesn't, I'm just going to leave it as the improper fraction 15 over 7. Reduce it if it will. You can always try it in the calculator. 15 divided by 7, hit enter, and then math, enter, enter, and it'll reduce it if it will and get you back to a fraction. If it doesn't reduce, it's going to just give you 15 over 7. That's what you want. Okay. Not too bad. Just multi-step problem there. Let's go to another. Let's throw some parentheses in there. 3 parentheses 2x minus 4 equals 24. So multiple ways to work this. If anybody tells you there's only one way to work a problem, they probably just don't know the other way. There's multiple ways to work this one. When I see those parentheses and a number out in front, what do I think about doing? What property is that? Distributive property. So my mind says, okay, that 3 needs to multiply to everything in that parenthesis. That's just what we've been taught our whole lives. So distribute the 3. So I'm multiplying 3 times 2x, and then I'm multiplying 3 times the negative 4. So I'm distributing that to both of those pieces. 3 times 2x is going to be 6x, and then 3 times negative 4. Yeah, so that's minus 12, and then we got 24 over there. Now it looks a lot like the problem that, at this step. So I'm going to get the x by itself. So I'm going to move that 12. How do I move that 12? Add it. So plus 12, 6x is equal, so that's canceling that out. 24 plus 12, 36. Ooh, that's a good number because I know my next step is to do what with the 6? Divide by this 6 because that's what the inverse of multiplying 6 times x is dividing by 6. And I know 6 goes into 36 6 times. And again, I can go back and check that in the original problem. 2 times 6 is 12. 12 minus 4 is 8. 8 times 3 is 24. So that checks in the original problem. So we can always go back and check our answers if we're not sure about it. So a little bit of distributed property there. Am I moving too fast? Let me know if I am. Slow me down. Ask a question. Make up a question if you need me to slow down, okay? I tend to roll on a little bit too much sometimes. So I'm going to do another one. Let's do 3 parentheses 2x minus 4 equals 7 minus parentheses x plus 5. This is a sneaky one. So a little bit of parentheses on both sides. So we got to be careful here. So what should we do with this problem? Where would you start? Okay, so I'm going to distribute the 3 to both of those like we did before. We've done that one already, so that's 6x minus 12. What about the other side? Distribute the negative. So this is like a negative 1 is in front of that. So we need to distribute that negative there. That 7 is not the thing that's distributed. That's the most common mistake that I see with this stuff is folks want to say 7 times x and 7 times 5. But that 7 is not the part that's in front of the parentheses. It's that negative 1 that's there. So we've got 7 minus x minus 5. I like to clean it up before I start moving things. So that right-hand side has got some stuff that can go together. The 7 and the 5 could go together because they're both just plain numbers. So what is that going to become over there? Negative x plus 2, or you could write it 2 minus x out of that. Since it's on the same side, don't change the signs when you go to put them together. So it's really just 7 minus 5. That's what that is. Don't do 7 plus 5. Don't change the signs unless you're crossing the equal sign. Now we got x's on both sides and plain numbers on both sides. Pick your poison as far as which one you want on the left and which one you want on the right. I like my x's on the left. Don't act like you don't keep up with your x's. I know you do. Maybe you don't. It's healthier not to. Your mental health and for your current relationships, for sure. So I moved that x over there by addition. So it's adding 1x. So if it helps you to put the 1 in front of that, do it. Okay? Don't hesitate to do that. That's fine. Now, 7 comes from 6 plus 1. Now I need to move this 12. How do I move that 12? Add 2 plus 12. Pretty boring here. This is easy stuff. That's going to be 14. That works out nice because now what's the last step? Divide by 7, and x is 2. So several steps there. I'm okay with you doing more than one step at a time. If you feel comfortable with that, do it. Some of you are more at different spots. We're all at different levels, and that's okay. I'm just doing it one step at a time because that's the easier thing. It helps us to keep track of where everything's going. Okay? Questions about that one? That one had a lot of stuff. Once. fractions. All right. Throw one to you here that's got everybody's favorite kind of number. Fractions. Everybody loves fractions, right? Shoot me an email. You got it. I'll try to. Awesome. All right. So, still the same idea. We want the x things on one side, the plain numbers on the other side, right? So, what do I need to move from that left side? At 2/3. It's a positive 2/3. So to move it, I'm going to subtract it. So minus 2/3. The good news is that I don't have to deal with the common denominator on this because they both have a 3 under the bottom. That makes that better. Doesn't make it great, but it makes it better. So I just subtract the top numbers. So the left side, those go away. I still have the negative 1/2 x. And then 7/3 minus 2/3 is 5/3. If you're apprehensive about doing fractions without the calculator, do them with the calculator. It's okay. But know how to do them. So alpha y equals, that's where your fraction button hides. So I have 7/3, and then press the right arrow key to get out of that fraction, minus, was it 2/3? Yeah, 2/3. Alpha y equals, the first thing, 2/3. And then it's going to give you a fraction back, 5/3. That's good news. Now, the last step on this one is to get x by itself. So how do I get rid of that negative 1/2 that's with that x? So dividing by negative 1/2, mathematically, what is that the same thing as doing? Not multiplying by 0.5, but multiplying by the reciprocal of 1/2, or negative 1/2. The reciprocal is -2. So I usually don't write it as division by a fraction. I usually write it as multiply by -2/1. Flip and multiply. -10/3. Because this side's going to cancel out. 5 times -2 is -10. 3 times 1 is 3. That doesn't reduce. If you're doing that with the calculator, be very careful about putting that in. So when you do your fraction, was it 5/3 divided by, and then you did -1/2? If you don't use that fraction button, I think it's going to give you issues. If you tried to put that in and did 5/3 like this, divided by -1 divided by 2, that is not the same number. Just so you know, that is not the same. You use the fraction button. It will save your life, okay, on those problems. So be careful of that. I tend not to use them, the calculator, unless I absolutely have to. All right, let's do another fraction problem because that's the ones we probably need the most practice with because we suck at fractions. Fractions are just part of math classes. As I told an English teacher today, he had walked by my classroom and heard me talking about as you decrease from negative infinity. We were talking about something in an algebra 2 class. He sent me an email and said, "I heard you say that, and I knew right then math was made up." And so I said, "Yeah, we just make stuff up to make it harder. That's what we do. We just make it up." I disagree with that. Math is not made up. Math was discovered. That everything works in math, and the world is all connected through the mathematics that happens. It's just kind of neat. Math wasn't invented, it was discovered. That's my philosophy on it. may not have that same philosophy, but that's my philosophy on math. Now, this one's got a lot of fractions in it. It's got a lot of stuff on the left-hand side. So on the left-hand side, you've got this 2/5 x plus 4/5, and then you have a negative 1/3 x. So you've got some stuff with x's on the left side. They're like terms. So this guy and this guy need to be put together. I'm not adding the 1/3 because they're on the same side. So I'm combining 2/5 and the negative 1/3. So I'm just still subtracting because it's on the same side. If I were moving across the equal sign, I would do the plus. But since they're on the same side, I'm going to use the same sign. Now, I'm going to do 2/5 minus 1/3. I can do that with the calculator. Alpha y equals fraction button 2/5 minus alpha y equals fraction button 1/3. Then I'm just hitting enter. It's going to give me my answer in fraction form, which is positive 1/15. So that combines to be 1/15 x plus 4/5 equals 7/8.
That's not a negative number?
No. 2/5 is more than 1/3. If you think about 2/5 as a decimal, it's 0.4. You think about 1/3 as a decimal, it's 0.3 repeating. So 0.4 is bigger out of that. Now, I'm going to show what I would have done without the calculator because I think it makes it make more sense about what's going on. I have to have a common denominator. So I'm going to multiply top and bottom by 3. So that's going to be 6/15x. I'm going to multiply top and bottom by 5. So that's going to be minus 5/15x. That's where the 1/15 comes from. 6 minus 5 is 1/15. So that's using the common denominator stuff. That's what the calculator did in the background. Is it took that 2/5 and said, okay, that's really 6/15, and it took the 1/3 and said, oh, that's really 5/15, and subtracted those. And got that common denominator and worked that out for us. That's what it did in the background. So that's how I got the positive 1/15. And then I need to get my like things together. So I have a fraction over here that doesn't have an x. I have a fraction over here that doesn't have an x. So I need to get those together. So how do I move that 4/5? Subtract it. That's right. So I have 1/15 x equals whatever that is. 3/40, positive or negative? Positive. 7 alpha y equals 8 minus alpha y equals 4/5. So positive 3/40. That's doing it with the calculator. If I were going to do this by hand, I would get the common denominator to be 40. I'm multiplying by 5, top and bottom. So that's 35/40. Multiply by 3 on the bottom. That's not by 3, by 8. Sorry. 8, not a 3. 8 times negative 4 is negative 32. And that's still 40 on the bottom. That's where the 35 minus 32 is where that 3 is coming from. Again, the calculator's doing that in the background. And I don't care if you do it with a calculator. It's fine with me. Not gonna hurt my feelings any. Maybe a little bit, but not. I'm not gonna go come haunt your dreams because you used a calculator to do a fraction problem. Get the right answer. Okay. Now, last step: get rid of the 1/15. So we're going to multiply by the reciprocal. The reciprocal is just flip it over. 15/1. X is all that's left on the left. On the right-hand side, you can multiply straight across. 3 times 15 and 40 times 1. And that's going to be 45/40. And then we're going to reduce that fraction. 9/8. Some of you may be thinking there's another way to do that. Y'all remember cross canceling from elementary school? 5 goes in 15 3 times, 5 goes in 40 8 times, and then 3 times 3 is 9, 8 times 1 is 8. So you could cross cancel. It doesn't get any faster. It's the same word. It's just doing one of them ahead of the other. I just assume multiply it straight across. And most of us probably doing that with the calculator anyway. 3/40 times 15. Getting 9/8 out of that. Okay. So all of these equations have one solution. They have one answer. Okay. That isn't always how it works. Okay. Sometimes you have some special cases happening. Okay. So let's look at a problem that maybe has a little bit of special case. -2. We'll go away from the fractions for a minute. -2 parentheses x plus 4 plus 3x is equal to x minus 8. Okay. So looking at this problem, what should we do first? Yeah, I think distributed property definitely. Order of operations tells me to do the parentheses and exponents and then multiplication division left to right. So there's some multiplication left to right there. So that's -2x minus 8 plus 3x equals x minus 8. On the left-hand side, I got a -2x and a positive 3x. When I put those two together, what do I get? I get x. And I have x minus 8 equals x minus 8. Well, that's weird. It's the same thing on both sides. If I were to try to get the x's together, what happens to both of them? If I were to try to get the 8's together, what happens to them? They cancel out, okay? So I end up with this 0 equals 0 thing. At this step right here, when they're the same on both sides, I can call it done right there. Because it's not going to get any better. It's just going to get less stuff, but it's still always going to be the same thing on both sides. What this is called an identity. And that an identity has solutions that it's all real numbers. An identity, the solution is all real numbers. Identity has the exact same thing on both sides.
Whatever you plug in, as long as it's the same both sides.
Yeah, as long as you plug in the same number for x on both sides of the problem, you get the same answer on both sides. It works. Okay, so identities, whenever you see it being exactly the same on both sides, you can stop right there and say it's all real numbers. It's an identity out of that. When it's got one solution, it's called a conditional. Not that that matters, but that's what it's called. Identities have all real number solutions. Conditionals have one solution. And then let's look at this next example. Example K, 3, and then 3x minus 1 in parentheses equals 9x plus 7. What would be your first step on example K? Distributed property. So distribute the 3. It's going to be 9x minus 3 equals 9x plus 7. If I go through my steps of solving this thing like I would have before, I would move this 3 over. And I'd have 9x equals 9x plus 10. And then if I move the 9x, what happens to the 9x's? They cancel out and I get 0 is equal to 10. Does $0 ever equal $10? No, that is never going to be true. This is a false statement. Anytime that's false, then it's what's called a contradiction. and that means that there's no solution. You could write out the words no solution, or you could do a circle with a slash through it. That means the same thing. Remember the symbol for empty set from way back in the first night we met? The empty set, that no solutions out of that. That's what that means. Okay. So conditional, one solution. Identity, all real numbers. Contradiction, no solutions. If you look at the mass of the examples we've done, what happens most of the time? We get an answer. If you're working problems and you get a bunch of them that are all real numbers or a bunch of them that are no solution, something's probably not going right. Because most of the time you're going to get one answer. You'll get x equals a number. Okay? That happens most of the time. These are special cases. Special cases don't happen that often. Okay? All right. Same section. We got 1, 2, 3, 5 more examples in this section. Okay? Still solving equations, but we're going to call them literal equations. Literal equations means we solve for one variable in the problem. Mr. Isbell, we've been doing that. The difference is that this problem has more than one variable in it. Everything we've had up to this point only had the one variable in it. It had x in it. I used x every single time. This one's going to have more than x in it. A good example of this would be something like this. 3x plus 2y equals negative 8. And they want us to solve that. My hand is not keeping up with my brain. Solve that for y. Okay? This is something that you've done a lot of over the years. You solved an equation, you got y by itself. That happens a lot. Okay? So a literal equation is going to have variables still in the answer. That's what that means. Literal equation just means you got variables in your answers. Okay? So if I'm going to get y by itself, that means I'm going to move everything that ain't got y. So I'm going to move that 3x. How do I move that 3x? Subtract it. That's a good idea. I'm going to write it 2y is equal to negative 3x minus 8. I wrote it that way because that's how I usually write it. I usually write the letter parts first. It's okay if you wrote negative 8 minus 3x. It's the same thing. There's one more step to get y by itself. Divide every single piece by 2. Divided by 2, divided by 2, divided by 2. Then work all those out. This side, that's y by itself. Negative 3 divided by 2, does it go evenly? No, so I'm gonna reduce that if it will. It doesn't, so it's negative 3 over 2x minus 4, because that does go into it evenly there. There you have solved a literal equation. You got y by itself. Your answer had x's in it. The only drawback to these is you can't plug that back in and as easily and check your answer. But it does, it's a literal equation. You're going to have variables in your answers. Let's do another. Do another one, same idea. 5x plus 4y equals negative 16 plus 12x. Oh, make that I'm sorry. I can't read my own handwriting over here. That's a 2x. Maybe I could, and I'm seeing double. I'm not sure. Solve for y. We're going to get y by itself when we get done here. Yeah, that's a great idea. That'd be a good move. Minus 5x. I'm going to subtract it from the 2x because there's like terms. It's going to leave me 4y is equal to negative 16 minus 3x Or if you wanted to write it in the other direction, you could write negative 3x minus 16. It doesn't matter. I don't care either way. One more step. Divide everybody by 4. So every piece gets divided by 4. Boom, boom. Negative 16 divided by 4. Negative 4. 3/4 on the other one. So it's minus 3/4. Whoops. 3/4 x. Or you could write it y equals negative 3/4 x minus 4. Those are both correct.
So if we swap them in the beginning,
It doesn't matter.
it doesn't
Yeah, I don't care either way. Know that on the multiple choice format, like on our Canvas quizzes, they may have it written like this, and you may have worked it like that, and it's okay either way. It's fine. Just make sure you've got the same sign on your pieces with those. Okay. Well, let's break away from that kind of problem and go to one that's maybe a little bit different. So let's do V equals L times W times H. Anybody know what that is? Volume of a what? Rectangular prism of a box, basically. Volume of a box. Out of that. So there's our equation. We want to solve that for the width. Solve it for W. So what's going on the right-hand side with all of those letters? They're all multiplying. So the inverse operation for multiplying is dividing. So what do I need to divide by to leave W there? L and H. So I'm going to divide by L times H. That's going to cancel out the L over there. It's going to cancel out the H over there. That's going to give me W equals volume divided by LH. The width of the rectangular prism is the volume divided by the length times the height. I don't know when you would ever use that, but we're in a math class. Who says you got to use everything we learn? You don't really have to know how to tie your shoes anymore. I mean, you could do Velcro your whole life, or Hey Dudes. They you don't have to tie them, or slip-ons. You don't have to tie those. So you don't really have to know how to tie your shoes, but we teach it to you, just in case. You may know what that formula is. Yeah, pi times diameter equals circumference. There's a book in the elementary school that talks about circumference in the Knights of the Round Table. I'm serious. My wife and I both teach math. You bet my boys heard that book before. So. Now, pi is not really a variable, but we can treat it like one, right? So how would I get pi by itself here? Yeah, divide by the diameter, or d there. So pi is the circumference divided by the diameter. And that works for any circle. You could measure the circumference of this marker and then measure the diameter of that marker. And when you divide those two things, it would be equal to pi, which is 3.1459, a bunch of numbers after that. You do those round clocks in the back, it'd be the same number. I think that's pretty neat. Them fellas that figured that out, it's pretty sharp. One more. Last one of this section. P equals 2 parentheses L plus W. Solve for L. Anybody know what that formula is? Perimeter, yeah, it's perimeter.
Equals 3 times the length plus 2 times the width.
Okay, so what did you do there?
Distributed the two.
Okay, that's absolutely fine. I don't disagree with that. That's not a bad idea. Probably makes you feel a little more comfortable. We're trying to get L by itself.
Subtract 2W on both sides.
Yeah, that'd be a good idea. Minus 2W. So that's P minus 2W. One more step.
Divide by 2 everywhere.
Divide by 2 everywhere. I like that. Divide by 2 everywhere. Does 2 go into P? No. Should be only 1 going into P, not 2. That's a joke. Come on. I didn't get it. You'll catch it later. You'll be like, oh, God, that was pretty good. So there's our L. 2 goes into 2 one time, so that's just 1W. So perimeter divided by 2, subtract the width, is equal to the length. So literal equations is just get the variable they ask for by itself. Do the inverse operations to get there. Okay? Questions about solving linear equations from section 1 there. 1.1. Section 2 literally has one example. Let's go ahead and do it. Find it here. 1.2. There is your example. Go ahead and copy that down. The perimeter of a rectangle is 40 inches. The length of the rectangle is 5 more than twice the width. Find the dimensions of said rectangle. So it's a word problem. The title of this lesson is Applications of Linear Equations. So when you read the word problem, know it's a linear problem. It's going to be an easy, small equation. It's not going to be really overly complex. The perimeter of a rectangle is 40 inches. So I got a rectangle. It has a length, a width, and a width. Maybe it helps to know the perimeter formula. Probably a good idea. We just used it in the last problem. That's kind of why I went to this problem. Now we got to build our pieces. It says the length is 5 more than twice the width.
So set that equal to 40.
What do you mean?
So you replace P with the 40 since we know that the whole
Okay.
is 40.
I don't disagree with that. Since we know the perimeter is 40, we can set that up. Now, I haven't used the stuff I underlined yet. Very good. The length would be 2W plus 5. That's what 5 more than twice the width. That's 2W plus 5. So now I can take that 2W plus 5, and that's the length, and I can put that in the place of that L, right? Because they're the same thing. It's supposed to be. So that's going to be 2 parentheses 2W plus 5 plus 2W. And that's supposed to be equal to 40. That's what perimeter is supposed to be, is 40. Now I've got a problem that only has one letter in it. It's got W in it. It's in 2 places, but I got only one kind of variable in there. So what can I do to solve that? Yeah. So that's 4W plus 10 plus 2W.
Add the 4W and 2W.
Yeah, they're like terms, so we're going to put those together. That's going to be 6W plus 10 is equal to 40. Now what?
Subtract the 10 from
Yeah.
5.
Minus 10. Every time I say yeah, y'all ever watch TikTok? Y'all know who Chit is? And every time I say yeah, in my head, I'm just hearing him say, yeah, yeah.
That's just right.
I don't know. Sorry, I'm ADHD. I can't stay. The 30 is equal to 6W by 6. W is equal to 5. So the width is 5. How much is the length? 15. I'm going to spell length correctly. 2 times 5 plus 5. That's 15. Does that add up to be 40 if I do the perimeter? 2 times 5 plus 2 times 15, 10 plus 30 is 40. Yeah, so that works. So there's my dimensions. So dimensions means the length and the width, both. They didn't say, it's in inches here, but that's not as big a deal. I'm not overly picky about that. I like the geometry related application problems. That's what I like. That's the ones I really tend to lean more towards. So when we go to test time, that's what you're probably going to see is those. Okay. Y'all need a break, or do you want to push on through? All right, let's take a short break.